recorded version of 1 through 4 from when we did it on Google Meet yesterday. So I'm going to skip to number 5 so that way you've got like more examples that you can look at too. But of course, if we need to go back and do number 4, we can. Or 1 through 4, we certainly can. But I'll start with this one. So you're not doing anything that you don't already know how to do. It's just that now everything you've been doing for the last week is all mixed together. So, for example, you're still factoring just like you were. You're still solving to factor. But you got to make the determination about whether you're going to factor or whether you're going to have to take a step after factoring and solve. So I'm going to show my computer to you so you can kind of see what I'm talking about. So for number 5, give me one sec to pop it up on the screen here. There we go. And I'll make this bigger. So we're going to pretend we skipped over to number 5 for a minute. And it doesn't matter whether it's an expression or an equation at this point, because you're really going to start off by doing the same thing. You're still going to start off by factoring it. So what would be like the first thing you need to ask yourself before you start solving it all?
You'd find the greatest common factor.
You would look to see whether there's a greatest common factor. Exactly. So is there a greatest common factor for this one?
No.
There's nothing we can divide. Oh, yeah, you're right. I'm on crack. Never mind. I was getting ready to say something stupid. You're right. So there's no GCF. So what's the next thing that you need to check for? It's got 4 or more terms, so you probably already know you're going to do what?
Would you see if it's quadratic?
You could. And so because that first exponent is a 3, is that going to be quadratic?
No.
Nope. Okay, and we know it's not going to be special because if it were special, it wouldn't have 4 terms, first of all. It would have just some perfect squares, so that's not it either. So what's the very last one where we have 4 more terms?
You'd combine them?
So we're going to factor by grouping. If there's 4 or more terms, and if I look and I see there's a greatest common factor that I can factor out of that group, and there's a greatest common factor that I can factor out of that group. So I'm going to use the strategy factoring by grouping. And remember, you can use that one if you have 4 or more terms, and there's a common factor that you can factor out of each group. So what am I going to factor out of the green group first of all?
8.
Okay, anything else you're right about the number. What else I can?
8p squared.
Exactly. So I'm going to factor that 8p to the second. And what's that going to leave me with after I factor out that 8p to the second?
4p minus 2.
24 divided by 8. I agree with the p. I agree with the 2.
Oh, 3.
Yeah, exactly. All right, so 3p minus 2. And then what is the common factor that we can factor out of the pink group?
3.
Okay, so we're going to do plus 3. And then what's going to be left over after we factor out of that one?
3p minus 2.
Yep. So how do you know that you're on the right track, that you've probably done this correctly so far?
The numbers in the parentheses are the same.
Exactly. You have that binomial in common. So do you remember what you do once you get to that binomial in common?
You'd do... You'd rewrite it as 8p squared plus 3 in parentheses.
Yep.
And then 3p minus 2 in parentheses.
Yes, ma'am. That's exactly what you do. Okay, so you factor out that common binomial, so it comes out, and then the leftover, the 8p squared and the plus 3 becomes the other binomial. So now we don't have a GCF anymore. We don't have 4 or more terms. I do need to look here to see if there's anything else I can do, because it is quadratic, but it's not a quadratic trinomial. And it's not special, so I do, which we remember special means those would have to be perfect squares. So that does tell me that we're officially finished because we've done everything we could do. Now, if the original problem had been an equation, what does it have to have in it to be an equation?
An equal sign.
Exactly. It would have to have an equal sign, and it would have to be equal to 0. But this one, of course, didn't have an equal sign. So that's why. Oh, sorry, go ahead.
I don't understand.
Oh, like what to do after you factor? Okay, so we'll do some equations in a second. The only other thing I wanted to point out to you was when you fill out the Google form later, make sure you follow the directions because it does, you know how the formatting's picky, but I like you being able to check your work as you go. So that's kind of the trade-off. But for the form to work, you need to put whatever the smaller constant is in first. So, yeah. So if I type it in the way I did it right now, it would count it as wrong, even though it's technically correct and it really doesn't matter. So you got to look and see which one of those numbers is smaller first, and then make sure that's the binomial that you type in.
Okay.
Okay, so we'll look at number 7. So number 7, we're going to pretend for a minute that equals 0 isn't there. Okay, because you still start off by, before you can actually solve it, you still have to like factor it. And since it's already set equal to 0, that's another thing that's important. You're going to have to do some manipulation if it's not already set equal to 0, but it is. Okay, so we're good. So what is the first thing you need to look for when you're figuring out whether or not, or how to factor this side?
The greatest common factor.
Exactly. And do we have a greatest common factor?
X.
Yes, you do. Good job. A lot of people have told me no. So good job noticing that this does have a GCF. So we're going to factor an X out of both of those. So I'm going to factor that X out of there, which means that for my leftover, I have X minus 1. Does that make sense so far?
Yeah.
Okay, so because now we know we're completely done factoring because this isn't special. It's not a perfect square trinomial. It doesn't have 4 or more terms. It obviously doesn't have a GCF because we factored that out of there. So now we know we're done factoring. That was a really easy one to factor. It was just a GCF. So now we have to solve it though. So remember that the way that multiplication works, for like 0 times anything is going to be equal to 0. So because we're trying to figure out what would make this equal to 0, and we're multiplying these two things together, either that X is equal to 0 or what's inside of that binomial is equal to 0. So one of our solutions is already done for us. We know that X would need to be equal to 0. And then to find your other solution, you just need to figure out what value for X would make that binomial equal to 0. So what minus 1 is equal to 0?
1.
Exactly. So your two solutions are those braces that I can't draw. X could be equal to 0. X could be equal to 1.
And that's all?
Yeah, that's it. The only difference is after you get done factoring, you have to decide you need to take an extra step and actually solve it or not. So let me go. Oh, number 8 is going to be a good one. So number 8, first of all, is it an equation or is it an expression?
Would it be an equation?
It is an equation. How do you know it's an equation?
The equal sign?
Exactly. So the second thing you got to make sure is you're not ready to solve it yet, but it still needs to be in the right format so that it needs to be set up equal to 0. So is it set up equal to 0?
No.
So what do you need to do to get it that way?
Could you subtract 2 by each
Yep.
side?
That is exactly what you're going to do. You're going to subtract 2, so that'll make that side equal to 0. And then you're right about having to do it to both sides. Now, of course, you can't combine an a squared or an a and a negative 2. So all you're doing is rewriting those 3 terms so that the negative 2 is over on the other side. But be careful and make sure that you write them in the right order, because the exponent with the 2 exponent needs to come first. The regular variable needs to go next. And then the constant that's by itself needs to go third, so that it's in standard form so that you get the right A, B, and C. Does that make sense?
Yeah.
Okay, so now it's set equal to 0. So we're going to factor it first, just like we normally would. So This part I feel like you know how to do, so I'm going to kind of whiz through that. So it doesn't have a GCF. It's not special. It's a quadratic trinomial, though, and A is not equal to 1. So what strategy do we have to use when it's quadratic trinomial and A isn't equal to 1?
The AC method?
Exactly. So we got to do A times C, which is going to be negative 10. And we have to figure out what multiplies to negative 10 that'll add to get 9. And in this case, that would be a positive 10 and a negative 1. Because if you multiply them together, they multiply to negative 10. And then if you add them together, they equal 9. So what was the whole point of getting that 10 and that negative 1? What do we do with them now for AC method?
You would replace that 9A with a 10 and a negative 1.
Yep.
Because it changes it to 4 terms instead of just having the 2.
Exactly. So I'm still kind of ignoring this equal to 0 right now. So I'm just going to I'm going to write the 5A squared plus 9A minus 2. And you're absolutely right. So we have to write the 9A as the difference of 2 terms. So it'll be 10A minus A. Bring the rest down. And I know you know how to factor by grouping, so I'm going to run through that part very quickly. So here we would factor out a 5A that they have in common. And here we would factor out a negative 1. So after I factor out that 5A, that leaves me with an A plus 2. And after I factor out that negative 1, that leaves me with an A plus 2. We know we've got the common binomial, so we're on the right track. So A plus 2. And then I'll have 5A minus 1. So we fully factored it because it's not quadratic anymore. We don't have 4 or more terms anymore. So now that we know we've got it fully factored, it's time to go back and deal with that is equal to 0. Because we need to solve it since this is an equation. So the way the multiplication works, either that needs to be equal to 0 or that needs to be equal to 0. So we've got 2 equations. We've got A plus 2 is equal to 0. And we've got 5A minus 1 is equal to 0. So if we solve them both, one solution for A is negative 2. And then one solution is going to be 1 over 5 because we want to leave it as a fraction. So your 2 solutions, the way you would type them into the form would be the negative number first and then the positive 1 over 5 second with the braces.
Okay.
So as long as you remember Friday's classwork, you're really fine. It's just knowing when you need to solve versus when you need to factor. Do you feel like you need to do another one?
No, I think I'm good.
Oh, okay. Awesome.
I was just confused by the equations because we haven't done that for a while.
Yeah.
So.
Yep, it's been a minute. But you're good now? Okay, cool.
Yeah, I'm good.
All right, just send me any kind of note or something if you need any more help.